Day 102, Hardness and Streak. Today's purpose is that you will learn how to identify a mineral's hardness and a mineral's streak. The relevance is that some people have a hobby of collecting minerals, and they use these kinds of skills in order to identify what they want to collect. Success. You'll be able to measure the qualities of a mineral. We'll be having different samples of 6 different minerals, and you'll be finding the hardness and streak of each one. Part 1, classwork review and notes. First of all, look at the vocab list at the front of the packet for the first 6 answers, and spend about 5 minutes doing the first page here. We have 10 questions at the bottom as well. So please pause the video and do those problems on your own, or you can work with your teammates, and in a few moments we'll go over the answers. Please pause the video now. Question number 1. A mineral is always inorganic, meaning that it comes from non-living sources. Number 2. A dietary mineral is one that we need to eat in order to keep healthy. Number 3. A mineral has a crystal structure, meaning that there are atoms or in a pattern. Number 4. A mineral's luster is described as either being waxy or glassy, metallic or dull. There are others as well, like pearly. Vitreous is the fancy word for glassy. And there are others as well. Number 5. A mineral's cleavage can be described as fracture or irregular. It's how the mineral breaks, whether it breaks into flat surfaces or not. Number 6. Is density the same thing as weight or mass? No. In fact, density and weight and mass are all referring to different things. Mass is merely how much stuff is in an object. Weight is how much the force of gravity is when it acts on that object. And density is how closely together the atoms are packed, how much matter is in each cube of the object, in other words. So all 3 are distinctly different things, yet a lot of people get those mixed up, and sometimes it gets confusing. Okay, notes. Number 1. A mineral is something that is always made naturally. Number 2, a mineral is always solid at room temperature. Sometimes people refer to oil and natural gas as minerals, but in science they're not. The most common reason for having unhealthy blood cells is because you aren't eating enough iron. Iron is the thing that keeps your red blood vessels red. Number 4. The most common reason for having unhealthy bones is because you haven't eaten enough calcium. Number 6. A 300-gram sample has a volume of 20 milliliters. What is the density? So you're going to take the grams, you're going to take the grams of 300 and divide it by the volume of 20, and that gets you 15. Number 7. A mineral sample is put into a graduated cylinder that has 11 milliliters of water. The volume level goes up to 29. What is the volume of the sample? So you take the higher value and you subtract the lower value, and that will give you the volume of the rock. Number 8. True or false? If one sample of granite has a sample color of red, then every sample will be red. That's false. Minerals can have an outer appearance that varies from one sample to another. Other qualities will be consistent throughout every sample, but not the outer sample color. Number 9. If one sample of granite has a streak color of black, then every sample will be black. That's true. Streak color is the same for every sample of a certain kind of mineral. Number 10. True or false? If one sample of donutite is 90% silicon and 10% krypton, then every sample has the same 90 to 10 combination, and that is also true. Chemical composition is the same for every single sample of a certain kind of mineral. The thing that really changes from one sample to another is the outer color. You can have lots and lots of different samples of quartz, and they have many different colors: pink, blue, green, white, clear. But if you take the streak of that, even though the outer color is different, the streak color will be the same for every single sample of that quartzite or calcite or whatever it is that you're looking at. Okay, next page, notes. There are a couple things here that have changed from the original writing, so beware of any changes that have happened here. Hardness, remember, is the ability of a mineral to scratch objects. The harder a mineral, the more it can scratch. The scale goes from 0 to 10, and it is called the Mohs hardness scale. M-O-H''S, Mohs scale. So there was apparently some kind of a geologist named Moh, and this was the scale that he developed. We won't do the whole scale in class, but we will do a few certain key numbers. If a mineral can scratch your fingernail or a sheet of aluminum, then its hardness is something more than 2.5. If it can't scratch your fingernail, if it cannot scratch aluminum, then it is softer than 2.5. Next, number 4. If a mineral can scratch a copper sheet, it has a hardness something more than 3. So a copper sheet has a hardness of 3. If you can scratch it, that means you're scratching it with a mineral that is harder than a number 3. If a mineral can scratch a steel plate, its hardness is more than 4. Steel has a hardness of 4. So if you can scratch it, the thing that you are using to scratch is something harder than 4. We don't know how high, but it's something bigger than a 4. Line number 6. If a mineral can scratch glass, its hardness is something more than 5.5. Glass itself has a hardness value of 5.5. If you scratch it with some other mineral, that means that mineral is harder than glass, so it has a higher number than 5.5. The hardest material ever known is diamond, and it has a value of 10. Over here on the side, I have a listing of the key things that we're going to be using over and over and over. If you can scratch a certain item with a mineral, then the mineral has a higher hardness value than the item that was scratched. Okay, examples. Line number 8. A mineral can scratch aluminum and copper, but not glass or steel. What is its hardness? Well, if it can scratch aluminum, that means that it has a hardness bigger than 2.5. If it can scratch copper, then it has a hardness bigger than 3. But this thing cannot scratch glass or steel. So that means that its number is not bigger than 4 or 5.5. It has to be somewhere between 3 and 4. A mineral can scratch aluminum, copper, steel, but not glass. What is its hardness? If it can scratch aluminum and copper and steel, that means that the mineral's hardness is bigger than all of these numbers. So it's bigger than 4. But it cannot scratch glass, so the hardness number is not bigger than 5.5. It has to be bigger than 4 because it can scratch steel, but it's not bigger than 5.5 because it cannot scratch glass. It has to be between these two, so it's between 4 and 5.5. A mineral can only scratch aluminum. It can't scratch copper or glass or steel. What is its hardness? If it can scratch aluminum, its hardness is bigger than 2.5. But it cannot scratch anything else. So it's not bigger than 3 or 4 or 5.5. So it has to be between 2.5 and 3. Number 11. A mineral can't scratch anything. What can we say about its hardness? If it can't scratch even your fingernail or aluminum, that means that it's not a higher hardness than 2.5. It's got to be less than 2.5. It's somewhere between 0 and 2.5. Okay, so those are all the notes about hardness. Now we're going to go on to another topic. It still deals with scratching things, though. Remember from last class's set of notes, the outside appearance of a mineral may vary from sample to sample, but the color of its powder form is the same for every sample. The name for this color is streak. It's the color of the powder that you make when you rub it on a tile of some sort. The most common way to see streak is to rub the mineral on a white or a black tile. So let's do some examples of this. Here is your Part 2 Scratch Project. This has been updated. Make sure that you have the updated version that has hematite, halite, magnetite, fluorite, corundum, and calcite. To do this, we have some mineral samples on a stick, all mounted. They're mounted just so that we can keep track of them. We don't get them all mixed up. We don't accidentally drop them and lose them. They can be taken off when you're scratching on these things. If they pop off, please just bring it to the attention of the teacher and we will use the hot glue gun to put them back on. No big deal. I anticipate that some of these will pop off accidentally, so it's no big deal. Please tell the teacher if something pops off. And then we have this plate here, this board that has all different kinds of materials on it. We have the black tile, white tile, pennies. The outside of a penny is coated with copper. Then we have steel washers, and we have a glass test tube. So all these different things we'll be rubbing the minerals on and seeing what happens when we scratch them. So let's first do the hematite. Hematite is going to be at the end here. The outside sample color is kind of a dark reddish black. You could describe it in lots of different ways. Let's first look for the hardness. So we're going to take the hardest material possible in our test kit, which is the glass test tube. And we're going to rub it on that. And there the rock popped off, so I'll have to re-glue that. But if I look carefully at the test tube, it did indeed scratch the glass. And so this is, the mineral is harder than glass. The mineral's hardness is more extreme, more hard than the glass's hardness. So the mineral's hardness is bigger than 5.5. Let's look at the streak now. I rub it on the white tile first. I can see that it's a reddish, brownish color. So let's call the streak either red or brown, reddish brown, something along that lines. So on your project sheet, I have here hematite. The hardness is greater than 5.5, and the streak is red or brown. Okay, next we have halite. Halite is going to be this clear material here. It's a nice cube. Notice that it has the flat surfaces on at least a couple sides. And so we would say that this has really good cleavage, makes very good flat surfaces. The hematite is much more like an irregular chunk of gravel. And so that does not exhibit good cleavage at all. It would be very poor, if indiscernible, meaning you can't see anything like it. Okay, so the halite, we're going to try to scratch things and see what it can scratch. First of all, we scratch the glass. And as I do that, I don't see any scratches at all on the glass. So the glass has a hardness of 5.5. Halite cannot scratch it, so halite is something less than 5.5. Let's try the steel washers. And the steel washers do not scratch at all. So steel has a hardness of 4. This is not stronger than 4. This is not harder than 4. So let's go to copper. I'm going to rub against one of the pennies here. And there is no scratch on that penny. So the halite is weaker than the 3 of the copper. It's less hard than copper's 3. So next we try to scratch our fingernail. And I don't see any scratches on my fingernail. So it's not even as hard as my fingernail. It has a lower density. Lower hardness. Fingernails are 2.5. So halite here is has a hardness less than 2.5. That's all we can say. We don't know if it's a 1 or a 2 or a 2.2. It's just less than 2.5 somehow. Okay, next we're going to be looking at this, which is magnetite. Let's first do... Oh, we never did do the halite's color, the streak color. The sample color is white or clear. Let's scratch on the white tile, and I don't really see too much. Let's try the black tile. And on the black tile we can see that it has a white streak. So halite streak is white. Okay, then you can just wipe that off with your finger. Okay, moving on to the third sample here that we'll do together, and that is this dark one right here. It's called magnetite. Magnetite is indeed magnetic. This magnet here sticks to it a little bit. It's not terribly strong, but a little bit. So, let's see here. We want to first of all find the hardness. So let's see if it will scratch glass. And I don't see any scratches on that. So magnetite's hardness is not 5.5 like the glass. It's going to be less than the glass because it can't scratch this. It's not as hard as the glass. Something less than 5.5. Let's try the steel washers. And here I can see some scratches. I don't know if you can see them on the video or not, but I can see some scratch there. So that means that the magnetite is harder than the washer. It's harder than the 4 of the washer. So it's something bigger than 4, but less than 5.5. It's harder than the washer, but less than glass. Okay, so now you have 3 more samples. We have this stuff, which is calcite, and then we have corundum, and then fluorite. The sample color of the calcite is going to be tannish, brown, grayish kind of stuff. But the streak is going to be different. And also remember that some materials will not have a streak at all. They are not able to make a powder by rubbing on the white or black tiles. So the answer of no streak is going to be used for one of these 3 things. I'll let you figure out which one that is. So do the hardness and streak for each of those 3 and report your analysis on Skyward, and then turn the page, and there are some homework problems in part 3.